My name is Jack DeGrave. I'm a business development scientist with FormFactor, and today I'll be introducing the cryogenic test and measurement product portfolio for FormFactor. So FormFactor's been a publicly traded company since 1993. We have about 2,200 employees worldwide, and over the last 12 months, we've done just over 700 million in revenue. What I'll be focusing on today is the cryogenic test and measurement product portfolio. So we span a temperature range from about 300 Kelvin down to 50 millikelvin. Beyond that, FormFactor has a wide range of probe systems and probe cards for both engineering and production applications, with a presence of about 8,500 labs worldwide. When it comes to quantum, we serve a couple main applications. One of the major ones right now is photonic device testing. We also do a lot of cryogenic characterization, including things like cryo-CMOS. And we have systems for high frequency devices as well. So FormFactor has really positioned its product portfolio to address the concerns of somebody who might be starting out the R&D and engineering level and then looking to scale that up either into engineering volumes or niche production volumes, and then going all the way up through full production, which include things like automated wafer prober systems and probe cards. We find that customers who get started early with us in the R&D and engineering phases are really able to improve device yield, and they get more data quickly, which ultimately accelerates the path from concept to volume production. Here's an overview of the major cryogenic products that we're currently selling. Each one of these products is also offered as a test service. So if you're not sure quite what product is going to get you the information you need, you can work with us on test services to try out the instrumentation. So on the far left here is our qubit pretest system. So this consists of an ADR cryostat with a 50 millikelvin base temperature. And it makes use of this PQ500 probe socket that I'll explain in a little bit more detail. After that, we have a 4K base temperature probe station. So this is shown in purple. Around the outside of the sample stage, you'll see independently manipulated probe arms, or at least nanopositioners that can be outfitted with probe arms. And then next to that in the blue is the rapid chip testing system. So this system uses a load lock interface to take a chip from 300 Kelvin down to 4 Kelvin in less than an hour. No wire bonding is required for a chip like this. And then on the far right in the orange is our new fully automated 4.5K wafer probing system. And this is the IQ3000. So this system can be equipped with over 56 RF contacts and greater than 300 DC contacts, and is fully compatible with probe cards. So one of the things we're seeing in the industry is we're seeing a lot of researchers trying to understand what they can measure at 300 Kelvin versus what they can measure at 4 Kelvin. Because ultimately doing test and measurement at cryogenic temperatures is much more expensive than doing it at room temperature. So FormFactor has products that can make those measurements at 300 Kelvin and at 4 Kelvin. And we've seen many customers able to really shorten their development cycles and improve device yield, which has really increased the speed at which you can go through a development cycle. And then the last product I'll introduce here is our qubit PreCharacterization system. So this system has really been designed for qubit and resonator PreCharacterization, especially for superconducting qubits and spin qubits. So here we're showing the PQ500 probe socket. This will accept bare singulated die, so no wire bonding and no packaging is required, and you can cool down a chip in less than 16 hours. So this allows researchers to find high-performing devices fast and really limit the number of failed cool downs in a dilution refrigerator, which is a time-consuming and costly cool down. So with that, I'll say that we're looking for partners and customers to help shape our product roadmap. We want to make sure that we're walking hand in hand with the quantum community. If you want to find out more about FormFactor, please check out the website at formfactor.com. We have global sales offices, and our cryogenic product line is manufactured and headquartered in Boulder, Colorado. Thank you.
So you guys are offering the whole gamut here. As quantum gets more mature, where do you see the most interesting areas of growth moving forward, or pain points solving for customers?
Yeah, I think one of the biggest things we're seeing is that there's still this fundamental uncertainty on what information can you obtain at 300 Kelvin versus what can you obtain at the low temperatures. And a lot of customers are working through that in different ways, and it also depends upon the particular modality that you're looking at. So for instance, photonic probing and some of the advancements there might require the lower base temperatures, especially when you're starting to look at integrated devices, things that might have photon sources, waveguides, and detectors all in a single chip. That's something that you really want to be probing at cryogenic temperatures. Whereas some of the test control or even some of the cryo CMOS stuff can be done at higher temperatures. So I think as we go forward, systems that provide customers a lot of data is really going to advance materials development programs, as well as some of the the fundamental structures that go into a quantum processing unit.
Okay, great. And then what new areas are you looking at as FormFactor looking at working in quantum? Anything that's not on this list here that you can tease us a little bit?
Sure. Yeah, I think one of the things we're really trying to do is develop a solid application engineering team to really help facilitate programs that are looking to scale up. So we've got the rapid chip test is a big project for us right now, the IQ 2000. So we think that's going to provide researchers with a lot of data very quickly at the chip scale level. We've noticed that a lot of people can really benefit by skipping the wire bonding process and getting data on their systems before that. So we're definitely focused on that. And then, looking at how might the automated wafer prober system need to scale to accommodate some of the quantum development programs out there. So, looking at larger wafers, more RF and DC contacts, and that sort of thing.
Mm-hmm. Awesome, awesome. Anybody else? Questions, Jack? I guess we may have some more at the end. Thank you, Jack.